Your Redis cache is working great, but now you've got multiple FastMCP servers all stomping on each other's keys in the same shared storage. We'll solve this by namespacing the cache with a prefix wrapper, so each server keeps its cached responses neatly isolated while still sharing the same Redis backend. You'll see how to wrap the base Redis store and configure the middleware to use it, keeping your distributed deployment clean and conflict-free.
From FastMCP server middleware caching, import response caching middleware. From key value, AO stores, Redis import Redis store. From key value, AO, wrappers, prefix collections import PrefixCollectionsWrapper. Base store equals Redis store, host equals Redis, example, com. Namespaced store equals PrefixCollectionsWrapper. Key value equals base store. Prefix equals my server. Middleware equals response caching middleware. Cache storage equals namespace store.
This demonstrates the storage abstraction pattern with namespacing, a common technique for managing shared resources in distributed systems. The code shows how to layer a Redis backend with prefix isolation, creating a dedicated namespace for one server's cached responses. What makes this distinctive is the separation between the physical storage layer and logical data organization, allowing multiple services to share infrastructure without collision. The pattern works by composing two concerns. The base storage engine handles persistence and retrieval, while the prefix wrapper adds logical partitioning. This follows the decorator principle, where behavior is added through composition rather than inheritance. The caching middleware remains unaware of the underlying storage details, interacting only with the abstracted key-value interface, which makes the system flexible and interchangeable. This approach solves the challenge of multi-tenant caching in distributed environments. Without namespacing, shared Redis instances risk key collisions between services. With it, you get isolation while maintaining shared infrastructure efficiency. The trade-off is minimal overhead for prefix management versus the operational simplicity of a single Redis cluster. This pattern becomes particularly valuable in microservice architectures, or when scaling horizontally across multiple server instances. Let's break it down line by line.
From FastMCP server middleware caching, import response caching middleware.
Imports response caching middleware, FastMCP's built-in caching layer for HTTP responses. This middleware intercepts outgoing responses, stores them in the configured cache store, and serves cached versions on subsequent identical requests, eliminating redundant processing.
From key value, AO stores, Redis import Redis store.
This imports Redis store, an async-compatible Redis client for key-value operations. It provides the persistent storage backend for our response caching layer.
From key value, AO, wrappers, prefix collections import PrefixCollectionsWrapper.
This imports PrefixCollectionsWrapper, a key-value store wrapper that automatically adds a namespace prefix to all keys. It prevents collisions when multiple services share the same Redis instance, ensuring clean separation of cached data.
Base store equals Redis store, host equals Redis, example, com.
Instantiates a Redis store, the async-compatible Redis client for key-value operations. This serves as the raw connection to your Redis instance at Redis, example, com, handling all low-level storage interactions before we add namespacing.
Namespaced store equals PrefixCollectionsWrapper.
This wraps the Redis store in a namespacing layer, preventing key collisions when multiple services share the same Redis instance. The prefix myServer isolates all cache keys to this specific service, ensuring clean separation between different applications. This is the standard pattern for multi-tenant Redis usage.
Key value equals base store.
This injects the base Redis store as the underlying key-value implementation. The PrefixCollectionsWrapper delegates all operations to this base store, while adding namespace isolation through the prefix.
Prefix equals my server.
Namespace isolation for cache keys. The prefix myServer ensures all cached responses from this middleware are scoped to this specific server instance, preventing collisions with other services using the same Redis backend. This is critical in shared caching environments where multiple services might use identical request patterns. This closing parenthesis finalizes the PrefixCollectionsWrapper instantiation, completing the namespaced cache store configuration. It ensures all cached responses will be isolated under the myServer prefix, preventing key collisions in shared Redis environments.
Middleware equals response caching middleware. Cache storage equals namespace store.
This instantiates the caching middleware with our namespaced Redis store as the backend. The middleware will automatically cache responses to identical requests, eliminating redundant processing while maintaining data isolation through the myServer prefix. This is the standard FastMCP pattern for adding response caching to your server. Distributed caching pattern. The Redis-backed caching middleware in FastMCP 2 demonstrates how storage abstraction enables seamless scaling, where the same caching logic works unchanged across in-memory, disk, and distributed backends. Namespacing your Redis keys prevents silent collisions when multiple servers share the same Redis instance. The write storage backend disappears. Your caching logic remains identical whether serving one user or 1 million.
The cache that remembers, everything forgets. It was ever there.